Hi everyone. Today we're going to be studying thermal conductors and insulators. So, uh, when we think about thermal conductors and insulators, really what we're thinking about here is one of those ways that heat moves, and of course I'm talking about conduction. You may notice a similarity between the two words, conductor and conduction. Remember, conduction is heat flow by direct contact, meaning touching. So, one of the properties that many materials or substances have is something called thermal conductivity. Thermal conductivity is just the ability of a substance to easily pass or really block the movement of heat through it. So, when we look, we have two basic groups. We have one group of materials that is going to pass heat very easily, and we have another group that is going to really block heat from moving through it. So, thermal conductors. So, when we say something is a thermal conductor, that is a substance that allows heat to move through it very easily. Mostly, when we think about thermal conductors, we are going to be thinking about metals. Okay, and so you can see that copper, aluminum, gold, those are all examples of thermal conductors. Now, when we look at thermal insulators, we're looking at those materials or substances that block heat and they keep it from moving through it easily. Some examples of thermal insulators are things like paper and wood, foam, rubber, plastic, cloth, all kinds of thermal insulators. There are, generally speaking, a lot more things that are thermal insulators than are thermal conductors. So why? What is the difference between a thermal insulator and a thermal conductor? Well, it really boils down to what's going on with the atoms. Thermal conductors are usually made of particles that are very, very close together. Remember, conduction is all about collisions. So when those particles are close together, it's more easy to have these collisions. You may notice too that in this picture, you can see that the atoms here are also organized very neatly. They're in rows and columns. This also aids in a substance being able to conduct heat. And all metals typically are what we call crystalline, and they would look like this picture. This is what the atoms look like in a metal, and so they are very close together and they're neatly organized. Thermal insulators, on the other hand, if we look at the way their atoms are arranged, thermal insulators are usually made from particles that are often very far apart and they're often very much disorganized, right? They're very random and spread out. Okay, so a thermal conductor allows heat to pass through it easily. A thermal insulator is a substance that really blocks heat and doesn't allow it to pass easily. So thermal conductivity, we said, is a property of all substances, and it's a property that can be measured. As such, we can look at the different thermal conductivities of substances and compare them. So if we look at this table that's here on the left-hand side, we're going to notice that we have a substance listed in one column, and then next to that we have a number that helps us understand thermal conductivity. So if you see a substance with a small number, that means that these are substances that are good insulators. Okay, and so as we look down this chart, I'm looking, and we can see like here's some very high numbers, but there are some that are like acrylic and air. Notice how these are less than one. So we have some decimals here, and the smallest one that I see, which is the smallest number, remember it's going to be a good insulator, is air. So if we look at this table, we can determine that air is a very, very, very good thermal insulator. Okay. Now, why might air be a good thermal insulator? Remember, we said that a conductor has particles that are close together. Well, air is a gas. Okay. So since the particles are so far apart, that is what makes it a very good insulator. So this is a thing that this idea of air and the particles being far apart, being a good insulator, this is probably something you knew even without maybe being able to say it. So you may know that many jackets that you would wear to keep warm, they're often very puffy, right? And oftentimes they're filled very loosely with some materials like feathers or another type of insulation that would trap spaces of air. And why? Well, what this does is it allows the heat to not be able to be conducted out away from you. It traps it up next to your body. So anything that includes empty space for air is a very good thermal insulator. So this jacket, a warm fuzzy blanket, all of those things are able to trap little air pockets. So we've said that air is a very good thermal insulator. So, and it's because there's very few particles and the particles are very far apart. So when we think of something like a thermos, and by thermos, I just mean like some sort of canister that we would use to keep things hot or cold. What makes those thermoses, those canisters, so good at their job? Well, the part that I care most about, I want you to notice that here on this thermos, on the inside, we have like a container, but then we have like this space around it, okay? And then we have an outer container. So for a thermos, we have an inner container, some space, and an outer container. Well, in this space, notice how it says that this is a vacuum. In this particular instance, the word vacuum means that there's no particles in there. That means vacuum means it's completely empty. Remember, conduction works best in solids. It needs particles to move. So a thermos works so well because literally there are no particles. It is all empty space. Okay, no conduction really takes place between this inner canister and this outer container. So thermoses are very good thermal insulators. If you were to look at things, some of you may have been around a home that's being built. This is the same thing. You've probably seen some insulation bats that look like this. They're like really just these big blankets that you put in between the wood that makes up the frame of the home. And they're often put into the ceiling and into the floors and into the walls. You can see that when you look at this, that there's lots of room for empty space for air. And so this is what makes it such a good thermal insulator. Uh, so some of these very light plastics, I'm going to call them styrofoam. I think they're called plastic foam. These are used on the outside of houses. Sometimes they're used in coolers. They also can be used in hot or cold drinks. Styrofoam itself, because you can see that there is a lot of empty space in there. There's actually little air pockets in there. So anytime we have empty space that's filled by air, we're going to be looking at a good thermal insulator. Now, some materials obviously are not insulators. They're going to be very good at conducting. And for that, when we look back at this table, we want to look for these higher numbers. So I see a number here, 429, 310, 401. But as I look at these higher numbers, I want you to notice these are all metals. So here's aluminum with a high number of 250, copper is 401, gold is 310, and silver is 429. So the higher the number in this table, the more we're going to find that is a very good conductor. And please notice that all of those are metals. And you know that comes down to, again, their atoms being close together and being organized, which allows for lots of collisions and lots of touching. Okay, so you know we use metals a lot in the kitchen because we know that they are good thermal conductors. So, you know, pots and pans are mostly made out of metal because we need them to conduct that thermal energy from the stove to the food that we're trying to cook. Glass itself, while it also has very organized particles that are close together, it is also another example of a thermal conductor. When we look at some things in the kitchen, though, we find that they're not all metal. So if we look at this example of a pot here, please notice it has a plastic handle. You know, think about that for a moment. You know, the plastic itself is a good insulator. So of course we use this plastic material because it is a good thermal insulator. So when we need to take the pot off the stove, the handle won't be hot and we won't burn ourselves. Some of the things that we might use to stir the food or to move it around inside the pots and pans, things like wooden spoons and plastic spatulas. If you think about that, those are all good thermal insulators, and that's why we use them in that job. So guys, thermal insulators and conductors. Remember, a thermal insulator is something that passes or blocks the flow of heat, whereas a thermal conductor is something that really allows heat to pass through it really easily. I hope you guys have a great day. Take care.